Hey, how's it going, everyone? Welcome back to day 14, I think, of the 30-day LeetCode challenge. Today's question is called Longest Palindrome. Now, I know I haven't been making a video on every day of this challenge, but I am trying my best to work with whatever time that I have after work. Anyways, let's get into today's question. Given a string which consists of lowercase and uppercase letters, find the length of the longest palindromes that can be built with those letters. This is case sensitive. For example, capital A, lowercase a, is not considered a palindrome, and we can assume that the length of the given string won't exceed 1010. So if we look at the example here, we have A, B, 4 C's and 2 D's, and the output is 7. It says one longest palindrome that can be built is DCC ACCD, whose length is 7. Let's break this down and look at how we can build this kind of logic on paper first. So let's say S equals AB, 4 C's and 2 D's. Okay, the first thought that I have is we don't actually want to construct a full palindrome from the given characters. We just want to see what the length of the longest palindrome would be. That's one of the mistakes I made when I first approached this question. I spent a lot of time actually building the palindrome, but we just need to find the length of it. Given that, the first thought that came to mind was the length of the longest palindrome can either be even or odd. So let me write that down. Okay, so understanding how an even palindrome is built and how an odd palindrome is built is crucial in understanding the solution to the problem. Again, this is just one of the ways that the problem can be solved. There are probably multiple ways of going about this, but I'm just going to explain the solution that I came to. So for an even length palindrome, an example of this would be A, B, B, A. So for an even length palindrome, you can imagine that there's a imaginary center line, and that on both sides, on the left side and the right side, the string is mirrored, right? We have AB and we have BA. Now, if we look at an odd length palindrome, for example, ABC, BA, this is length 5, this is length 4. For the odd length palindrome, instead of having an imaginary line going through the center, we actually have a character in the center of our palindrome. So this is one of the things that we're going to include in our logic. So first of all, we need to get a count of how many times each character occurs in the string. So let me write what the dictionary for that would look like. So this is the frequency count for all the characters in our example string up here. One thing that I noticed is that anytime you have an even number for occurrences for a character, you can always make a palindrome off of that. So for example, with these 4 C's, we can always make a palindrome because we have our line in the middle and on both sides it's mirrored. Same thing with D. It occurs twice, so we can add one D on this side and one D on this side, and we can maintain our palindrome. Now the question is, what do we do when we come to a character that occurs an odd number of times, such as A and B? So for example, for A, we can add it to our palindrome because instead of the imaginary line in the middle, we can just put an A, right? And it still maintains the fact that we have a palindrome. But now we can't add B because there's no way to add it into our string without making it not a palindrome, right? We can't add a B here because then this side, the right side, does not mirror the left side. So we're going to leave B out. And this is the longest palindrome that you can build for this string. And the length is 1, 2, 3, 4, 5, 6, 7. So let me break down into steps the logic that I used to get to this point. All right, so here I've broken down the steps that will follow. First, we're going to loop through all the frequencies. In other words, the character counts. So we're going to be going through these values of our dictionary. All right, and as we're going through, if the count we're at is even, such as 4, or C for 4, then we'll add that count to the palindrome count, also called pal count, because we can always add an even number on both the left and right side of our palindrome. So anytime we encounter an even frequency, we can add it to our palindrome count right away. So if the count is odd, we need to first check if we can add this character to the center of our palindrome. In other words, if there's nothing in the center yet, then we can add one character to the center and we can add the rest of the odd number of characters to the left and right side. So we can increase the palindrome count by that count if there's nothing in the center. Or if there is already something in the center, then we check if the count of odd characters is greater than 1. If it is, then we'll subtract 1 from the count to make it even, and we'll add it to our palindrome. So let me show you another example that can make these steps a little bit more clear. So for this example, we have A, 2 capital A's, 7 C's, a B, and 3 D's. Okay, first let's build the frequency count for the characters in this string. All right, so let's go through these steps. So we're gonna go loop through our frequencies. So we'll start with A for 1. All right, as we can see, the count is odd. So what we'll do is add it to the center, because currently our palindrome is empty and we can add an odd number of A's to the center of our palindrome. Or we can add 1 A to the center of our palindrome. Okay, so for capital A, it's an even number. So we can definitely add 1 A on either side of the palindrome. Now we have 7 C's. So what do we do here? Can we add it to the center? We've already added something to the center of our palindrome, so we're not going to do that. What we'll do is check here. The count of C's is greater than 1. So we're going to increase our palindrome count by the number of C's minus 1. In other words, we can't actually add 7 C's in here without making this unbalanced. So what we want to do is add only 6 C's. That's why we're taking the 7 and subtracting 1 here. So we can put 3 C's on the left and 3 C's on the right. So the maximum number of C's we can take is 6, while keeping the palindrome balanced. So let's look at B. We can't add B because we already have something in the center and our counts for B is not greater than 1. So we're not going to add B. What about D? Well, it's the same situation with 7. It's an odd number, right? So we can't add it to the center because, again, we already have an A in the center of our palindrome. So what we'll do is take 2 of these D's and put 1 on either side of the palindrome here, like this. So the maximum length of this is 11. I also do want to just clarify that in the code, I'm not going to be building this entire palindrome as a string. I'm just going to be keeping track of the length and what that length would be if I were to be building this palindrome. I was just doing this here to illustrate how the palindrome would look as we're looping through the frequencies of our characters. All right, so let's look at an implementation of this in Python. Okay, so we're starting off with the basic code that the question gives us. Now remember, the first thing that we want to do is construct the dictionary that contains the frequency of how many times each character occurs in the string. So there's many different ways you can go about doing this. You can use a counter from collections. You can use the get method. I'm going to use one of the most basic methods. I found that it gives me the best runtime. So from what I've tried so far. So here's what mine looks like. So we'll initialize a character dictionary as empty, and then we'll loop through all the characters in our string. If the character we're looking at already exists in our dictionary, then we'll increment its value by 1. If it doesn't exist, then we'll initialize it to 1. Okay, so by the end of this for loop, we should have a dictionary that contains the frequency of how many times each character occurs. Next, what we want to do is initialize our palindrome length to 0. And we need a variable that keeps track of whether we've added a character to the center of our palindrome or not. So we'll call it added center, and we'll initialize it to false. Now, as we saw in the example on paper, we want to go through all the values in our dictionary. So we'll say for val in character dictionary.values. Now, first we want to check if this value is an even number. So if the mod 2 equals 0, then we can right away add it to our palindrome length. If this if condition was not triggered, we know that this character occurs an odd number of times. So now we need to check if we're able to add it to the center of our palindrome. So if we have not added to the center of our palindrome yet, then we can increase palindrome length by the value, because we're able to put one of the odd characters in the center of the palindrome and put the rest remaining on either side of the palindrome. So we're able to use all of the characters from that. And then we will set added center to true. So what if we have a case where we have an odd number of occurrences and we've already added to the center? Then we need to check this. If that value is greater than 1, then we want to subtract 1 from the value so that it becomes even, and then we can add half of it to one side and half of it to the other side of the palindrome. In other words, we can keep value minus 1 occurrences of that character. So we can say the palindrome length goes up by value minus 1. And after we've gone through all the values in our dictionary, we can just return pal length. So let's run our quick test and see what the answer is. So one little mistake I made here was this if should actually be an else if. Now if we run our code, we can see that the same example that we did on paper, we get the answer we expect, which is 11. Now, if you want, you can run some more tests and see how that works for you, but I'm going to go ahead and submit this. All right, so the runtime beat 90% of other submissions, which is okay. And the memory could definitely be improved. But for the sake of time, I'm just going to leave it there. If you guys have any advice or suggestions on how I can increase the usage of space here, leave comments and let me know. If you guys learned anything new, found anything interesting in this video, then please leave a like and subscribe, and I'll see you in the next one. Thank you.